All right, part 2 of chapter 4, section 3 is going to start here with the properties of the logarithms. And you've probably seen these in the past, but we're just going to refresh our memory and then, do some practice problems. You can read through this, but I'm just going to kind of paraphrase it real quick. The product property of logarithm just basically says that if two things are being multiplied together and they have that same base number, that you can rewrite that as two logarithms being added together. The quotient property says if they're being divided, you can rewrite them as subtraction, two logarithms being subtracted. The power property says anything raised to a certain power can actually be brought out in front and multiplied by the entire logarithm. Okay, so if you've not seen this in a while, it may be a little overwhelming, but let's just do some practice problems. Starting with example 4. Okay, now this is an example of the product property, which states that if two numbers are being multiplied together, that it can be expanded or rewritten as two logs with the same base, of course. So let me rewrite this. So it would be log base 6 of 7 plus log base 6 of 9. So these two things, this and this, actually give us the same answer. If we type that into the calculator, we would get the exact same number. So it's just two different ways of working with logarithms, whether you want a more condensed version or whether you want a more expanded version. And they do both have their advantages and disadvantages, okay? And hopefully you'll see that as we continue to work some of these out. The second example, number 5 here, example number 5, is an example of the quotient property, which says that if they're being divided, that they can be rewritten as a subtraction problem. Now, the only thing I want to caution you about on this one is that if it is a division or a subtraction problem, the order 100% matters. So the number on top has to be the number that you start with in the subtraction problem, and the number on bottom goes second. So just make sure you don't get those mixed up. Excuse me. Okay, and example number 6, we have log base 5 of 8, or the square root of 8. Now, at first you're probably thinking, okay, I know we're going to do power property here, but there is no exponents in this. Well, I want you to think about it for a second. If you rewrite this radical, that's actually the same thing as 8 to the 1/2. So it actually does have an exponent, which means that the power property can be used here. And so in the power property, the exponent will actually come out in front of the entire logarithm, and that's it. That's all you have to do. Just multiply the whole thing by 1/2. Okay, so we were doing one at a time there. We just did one example of the power, of the quotient, and of the product property. But now, starting in example 7, they're going to mix them all up, and, they're going to say, good luck, and let's go. Okay? My advice to you is just to do this kind of one part at a time. This is a longer problem, so it is going to take us a little bit of time here. I started off by just simply getting rid of the fraction part of it, which was the division, right? So to do this step by step, I started off by saying, okay, well, if I want to write this, I might need a little bit of room here, so let me see. No wonder this is a 2-part video. I can't even get, there we go. Okay, so I started off by saying, okay, log of A, and then I put this in parentheses. I said M in Q, oh my, minus, because I do know it's going to be a subtraction. Let me get this stuff to go away. I don't know what's happening. There we go. I know it's going to be a subtraction problem because it is a division. But then I rewrote the second one in parentheses as well. Okay, so that's just, I started off just doing something simple, one step at a time. Then from here, I looked at the first part of the problem and I said, okay, well, M, N, and Q are all they're all being multiplied. So that's addition property. So, or will actually be product property. So I rewrote this first part. So n plus log of a n plus log of a of q, and then minus, and I'm putting this whole thing in parentheses now so that we know, that everything in here was divided by all of that at the very beginning. Okay? And technically, I guess it should all be in parentheses, but it'll be okay. Now let me look at the second part. So I've kind of cleaned this up. I've got them kind of as expanded as I can over here on the left side. But the right side over here, I see I have two power properties. I have the p squared and the t to the fourth. So I'm going to rewrite this second one now as, and I'll start off by saying 2 log a of p. Now, because this is being multiplied, I need to put an additional plus sign right here as well. So plus, and then the 4 will go in front. So 4 log a of t. Okay? And then if you rewrite the rest of this, we should be finished. We are good to go. All right, and that's it. That is your fully expanded problem. Now, hopefully we don't have too many that are that long, because that would be painful, right? Let's look at example number 8. Okay, example 8 wants us to expand this. And anytime you have radicals with logarithms, you definitely want to rewrite those as exponents first. So let me do that first. So we have log base a, and this is of course going to be a cube root. It's going to be m to the, and it's always the exponent over the index. So m raised to the 2/3. Okay? Once you have it written as an exponent, then you're going to take the exponent, bring it out in front. So now we have 2/3 log base a of m. And that was it. That one was pretty simple. Okay. And now for the big one here at the bottom. First things first, let's rewrite all of that as an exponent instead of a big radical. So log base b of all this stuff on top, z raised to the m. I have never in my life. Okay, and then when we start to write this as an exponent, all of the stuff under the radical is raised to the first power. So it's going to be 1 over n, because it was to the nth root. Okay. And then, to make all of this so much fun, we're going to do the power property first. So I'm just going to write this over here. It's going to be 1 over n and log a of all of this stuff. So x to the 3rd, y to the 3rd, over z to the m. 2 parentheses. Okay. Now the only on this is that you're going to have a 1 over
pick up where I left off here last time. I worked out this problem, but I didn't really explain very well what the E was. And so I just kind of wanted to
Okay, so I'm back. I'm sorry. I had to stop my video. I was exporting it and it finally stopped. Okay, so the thing you have to remember is that we have to have 1 over n in front of every single one of the expansions that we do here. So I'm going to do the same thing I did last time. I'm going to start by undoing the division. So 1 over n and then log a, and I'll do everything on top. So x to the 3rd, y to the 3rd, minus log a of everything on the bottom, so z to the m. All right, and now I'm going to break up just this beginning thing here. So I do have 3's out in front of both of these. So what we're really going to have here is we're going to have 1 over n, and then we'll say 3 log a of x plus 3 log a of y minus, okay, and I actually need, I'm going to do brackets here instead of parentheses. That way it's a little less confusing. But this is going to be in m log a of z, and I'll just finish that up with brackets. Okay, and then last but not least here, I just kind of want to clean it up and go ahead and it's almost like I'm going to be distributing that 1 over n to everything inside of these parentheses. So we're going to have 1 over n times 3, which is just going to be 3 over n log a x plus 3 over n again log a y. Now I'm going to keep all this in parentheses because there was that subtraction portion to this. However, the 1 over n does go with m as well. So this is m over n log a z, and we're done. Now that one is fully expanded. Okay, we're going to use, actually, you know what? I'm going to stop and we'll just do this in a 3-part series. And, you know, I hate that the videos are so long, but I just want to make sure that I'm as thorough as possible when I'm explaining how to do this.